Precast concrete is an inert material and does not contribute to poor indoor air quality. Furthermore, since precast concrete can be erected quickly, buildings are enclosed faster, providing a barrier between outside contaminants and moisture, while shaving months off a project schedule. In many cases, precast concrete can be left exposed on the interior of a building, eliminating the need for drywall, reducing waste, and increasing the overall durability of the interior finish. Precast concrete also does not provide a food source for mold, thereby helping to improve indoor air quality. Precast concrete provides flexibility in design. Designers and precasters work together to come up with innovative ways to be more sustainable. An example of this is the Cancer Genetics Research Center at the University of Florida, Gainesville. This project used thin brick veneer cast into precast concrete wall panels instead of traditional hand-laid brick. This decision saved over 1,150 tons of mined clay, which is enough clay to clad over 4 other similarly sized buildings. It also saved over 12,600 gallons of diesel fuel that would have been used to transport the full-size brick, and shaved almost $69,000 in material costs. Ultimately, the owners and designers were able to preserve the look and feel of the building while utilizing a more sustainable solution. Concrete is very durable and has been around for hundreds of years. Precast concrete does not combust, rot, or rust. In fact, precast concrete can be designed for a 100-year service life or more. The Precast Pre-Stressed Concrete Institute conducts research in conjunction with universities, government agencies, and other organizations such as the Charles Pankow Foundation in order to improve the design of precast concrete structures. Some examples of this research include the seismic program, which has been done on wall and framing systems and more recently diaphragms, with the DSDM or Diaphragm Seismic Design Methodology Program.
The precast concrete structures industry has always been a leader in design and technology, and we've done that by conquering any barriers that we've encountered to using our precast concrete building systems. And for a long time, nobody would consider building a precast concrete structure in a seismic zone like California. With our press program, we started breaking down those barriers, and now we're going for the gold. It's not good enough that precast concrete is okay to use in a seismic zone. Okay, we want it to be the best system to use. And in fact, this demonstration and this whole project is really advancing us more in that direction, where precast concrete systems are the best systems to use in seismic areas, as opposed to what used to be not recommended system.
Precast concrete structures can be built to not only withstand everyday loads and forces, but their inherent strength and properties also provide longevity against the extreme and powerful forces of nature. This not only can save lives, but can help reduce the environmental impact related to rebuilding due to storms, tornadoes, fires, and earthquakes. An example is the impact testing performed on precast concrete sandwich wall panels, which have proven superior resistance against projectiles launched at 100 miles per hour. The Precast Pre-Stressed Concrete Institute is conducting a life cycle assessment to better understand the environmental impact of precast concrete. The full research program includes a cradle-to-grave LCA of underground products and a cradle-to-grave comparative LCA of commercial buildings. Preliminary results suggest that precast concrete sandwich wall panels provide an extremely energy-efficient envelope system when designed correctly. The results are also being used to help identify areas where manufacturers can reduce their environmental impact. Several precast concrete manufacturers have already implemented many sustainable practices, such as zero-waste programs, upgrading to more energy-efficient equipment, and implementing recycling programs.